right, so we are going to continue with lesson 5.3. I'm going to break it down into kites and then trapezoids. So the kites had a number of conjectures, so let's go through those. The kite angles conjecture said that the non-vertex angles of a kite are congruent. The kite diagonals conjecture said that the diagonals of a kite are perpendicular. The kite diagonal bisector conjecture stated that the diagonal connecting the vertex angles of a kite is the perpendicular bisector of the other diagonal, meaning not only does it form a 90-degree angle when they intersect, but it also bisects the other diagonal. And then the kite angle bisector conjecture. The vertex angle of a kite is vertex angles of a kite are bisected by a diagonal. So, lots of information there about kites. Let's take a look at the trapezoids. So, trapezoid consecutive angles conjecture. The consecutive angles between the two bases of a trapezoid are supplementary. So it's not talking about the two base angles on each side, it's talking about one of the base angles paired up with the other pair of base angles. The isosceles trapezoid conjecture. So if you have an isosceles trapezoid, meaning the two non-parallel sides are congruent to each other, the base angles of an isosceles trapezoid are congruent. And then the isosceles trapezoid diagonals conjecture, the diagonals of an isosceles trapezoid are congruent. So nice, easy conjectures to use. Our goal again is to be able to have these conjectures memorized, the names of the conjectures memorized, kind of like vocabulary terms, so that you can use them in your proofs. Let's take a look at a couple of examples of how we would solve questions regarding trapezoids and kites. You should recognize these from your assignment. For the first one on the left-hand side, we have a trapezoid with us, and we can tell just by looking at it that it's not only is it a trapezoid, but it is an isosceles trapezoid. And we tell that because, of course, we see the two congruent markings. So we want to figure out what x and what y is. Well, we can see the y is over here, and x is over here in the corner with the angle. So let's go ahead and figure out x first. Well, if it's an isosceles trapezoid, that means this angle and this angle is congruent to each other, because those are the base angles on that side. So that would make this one 81 degrees. And then that would tell us that the consecutive angles, the two angles that are not base angles to each other, but one's a base angle of the other side and one's the other base angle, then those are going to be supplementary. So 81 plus x is equal to 180. Subtract 81 from 180, and x is equal to 99 degrees. Again, don't forget your label. Then we want to figure out the perimeter. Well, if it's isosceles, that means this side is going to be equivalent to y plus 12. And with all perimeter questions, add up the sides. So we have y plus 12 plus y plus 12 on the other side, and then we have y minus 12. You want to put parentheses around these, that'll help keep those four sides in line. And all of that is equal to 164 centimeters. So when we combine like terms and we simplify this, we get the equation 4y plus 12 is equal to 164. So subtract 12, divide by 4, and y is equal to 38 centimeters. Again, don't forget the label. Alright, so trapezoids are pretty easy, especially when they are isosceles trapezoids. Let's take a look at the kite question. So it tells us in the instructions that FLYE is a kite. Kind of funny, fly is a kite because you fly a kite. No. Anyhow, so FL is equal to LY. So FL is congruent to LY. So that tells us that these two are then congruent to each other, because we know with kites, the consecutive sides are congruent. Find W, X, and Y. Okay, so we have vertex angles here and here. Angle L and angle E are vertex angles. So the diagonal that is connecting those bisects the diagonal connecting the non-vertex angles. So that means this is going to be congruent to this. Alright, so if one half of that, if FR is 1.6, that means RY, which is W, lowercase w, is also going to be 1.6. All right, so there's one of the variables down. Now we got to take a look at the other ones. Let me erase something in here so you can see where the y is. Kind of hovering, hiding it over here. Okay. Well, we already know that, well, if this side is congruent, this one's a 90-degree angle, and this side is a common side, then using side angle sine, we can say that triangle FRE is congruent to triangle YRE. Okay? So then that tells me that angle X, too many dots going on here, angle X is congruent to 48 degrees using CPCTC. If we can prove the triangles are congruent, then we can prove corresponding angles are congruent. So then using our triangle sum conjecture, I have 90 degrees here, 48 degrees for angle X, plus whatever Y is, all equal to 180 degrees. So subtract 90 plus 48 from 180, and Y is equal to 42 degrees. So lots of nice, easy conjectures that we were able to use, bringing everything together. So talking about bisectors, talking about perpendicular lines, talking about triangles, all of this corresponds together using our kites. So that's pretty easy. Now, let's take a look at a question that really stumped a lot of you in class. And if you're in the honors class, you haven't gotten to this question yet, so this is giving you a little bit of a heads up. But you'll see something very similar to this on your test. So good to know. All right, so the question said to write a proof. So when you see write a proof, use any different scenario that you want. You can write a proof using the flowchart method. So maybe you've caught on to the picture that the textbook uses, and you might like that. Some of you have seen the two-column method that I use, and some of you have seen the paragraph method. So pick whichever method you want to make your proof, and then go from there. I'm using the picture from question number 9. If some of you remember, this is from question number 10. So I'm using the picture from number 9 to help us prove this kite diagonal bisector conjecture. So we want to use our proof to prove the conjecture. We proved it already with our investigation and using our picture, and now we want to prove it mathematically. Okay, so step 1 is, of course, given the information. So I like to do my two-column method. So here's the information, and then y. So here's the proof of it. So the first thing is that we can see that by is congruent to be, and we can see that yn is congruent to en, and both of those are because that's given information. The markings tell us for that. And then we know that bn, of course, is congruent to bn because that's a shared side, or a common side, or however you want to put it, same side, any different way to say that. So that gives me enough information then to say that triangle BYN is congruent to triangle BEN. And the reason why, as we all noticed in question number 9, is because of side, side, side. So the side, side, side conjecture tells us that. All right, so what's the point of proving these two triangles congruent? How does that help me prove the kite diagonal conjecture? Well, remember that the kite diagonal conjecture tells you that the diagonal connecting the vertex angles bisects the diagonal connecting the non-vertex angles. And remember that it not only bisects it, but it forms 90-degree angles. So if you're looking at the triangle, let's look at triangle BYN, for example. That segment going from Y down to side BN is the height of the triangle. And if we have proven that the two triangles are congruent to each other, then we are able to prove that the heights, the heights triangle are congruent. And the reason why is because of C, P, C, T, C. So the heights are congruent, and because the two heights form YE, then that tells us that EN bisects YE. Alright, since the two heights are the two sides, then, and we're not necessarily putting a point there when they meet, then they form the two equal parts. So that's proving that it is a bisector. And that's really it. When I'm talking about proving a statement, draw an example. In this case, we used a previous example. Draw the example, and then show it mathematically. Use the conjunctions we already know to go from there. As usual, if you have any questions, feel free to email me or come see me during breaks. If not, I will see you in class.